All right, so on Wednesday we talked about something called a z-score, which helps us to compare data to the mean based on the standard deviation of a data set. But what if we have two different data sets with completely different ways of measuring data and we want to compare them? Well, z-scores can help with that. Z-scores can help when comparing values from different data sets. Remember, a z-score is the number of standard deviations a value is from the mean. We talked about this a little bit on Wednesday, but how we calculate the z-score is we take the value that we care about, which we call x, subtract the mean, and then divide by the standard deviation. And z-scores, because this always tells us the standard deviation from the number of standard deviations from the mean, it can help us compare two completely different data sets with different means and different standard deviations. So let's do some examples to see how z-scores can help us compare data sets. So two students, John and Allie from different high schools, wanted to find out who had the highest GPA when compared to their school. Use z-scores to determine which student had the highest GPA when compared to their school. So we can see here that John's school uses a 4-point GPA scale and Allie's school uses a 100-point GPA scale. So it's really hard to compare these unless we have something like a z-score, which help us standardize the data. So the data points that we care about, our x value, are 2.85 and 77. Our mean is 3.0 and 80. That's our mu value. And our standard deviation is sigma. So let's calculate how far John's GPA is away from the mean. How many standard deviations away is it? So if we look at John, his z-score is equal to x minus mu divided by sigma. His GPA is 2.85. The mean GPA, that's mu, is 3. And the standard deviation is 0.7. This is equal to negative 0.15 divided by 0.7. And this is equal to 0.21 negative. This means that John is 0.21 standard deviations below the mean. Standard deviations below the mean. So that's how his GPA compares to his school. What about Allie? If we look at Allie, her school's GPA system is based on a 100-point system. So her z-score is equal to x minus mu divided by sigma. Her GPA is 77. The mean GPA is 80. And the standard deviation is 10. So this is negative 3 divided by 10, or negative 0.3. So what does this tell me? This says that Allie is 0.3 standard deviations below the mean. So John and Allie wanted to compare their GPAs to each other based on their school's average GPA. So if I were to get a number line here, here's my mean. I see that John is 0.21 standard deviations below the mean, so maybe this is John. And Allie is 0.3 standard deviations below the mean, so she's slightly further. So since John is less far away from the mean, we see that his GPA is better. John is closer to the mean. So he had the higher GPA. Compared to his school. Okay, so that's how we can use z-scores in order to determine how two data sets compare to each other. Let's do one more example. Ruth took 2 midterms this week and wants to determine which one she performed better on relative to the class's distribution. Given the following data, on which test did she score better? So we have a chemistry test and a psychology test. She has scores of 77 and 81. She has mean scores and then standard deviations. So sometimes when you take a test, the thing that really matters is how did you compare to the average? So that's what Ruth wants to see here. How do her two scores compare to the average? So let's compare our two z-scores here. We have chemistry. Remember, our score that we care about is our x value. The mean is mu, and the standard deviation is sigma. So for chemistry, her z-score is equal to x minus mu divided by sigma. This is 77 minus 75 divided by 3, or 2 divided by 3, which is 0.66. This tells me that she is 0.66 standard deviations above the mean. Okay, what about her psychology test? Well, this z-score is equal to x minus mu divided by sigma. Her score for psychology was 81. The mean was 80, and the standard deviation was 5. This gives us 1 divided by 5, which is 0.2. So her psychology score is 0.2 standard deviations above the mean. So we can see here that her chemistry score is relatively higher than her psychology score because it is more standard deviations above the mean. So Ruth scored comparatively better on her chemistry test. Comparatively? I don't know how to spell that word. Compare. On her chemistry test. And again, here we had two different data sets with two different means and standard deviations, but z-scores are a great way in order to compare two data sets with each other. Alright guys, we have made it to the end of the material for this course. Best of luck on the final exam and all of your final exams. It's been a joy to have you all in class this term, and I will maybe see you later. So have a great day.